Welcome to the Long COVID podcast with me, Jackie Baxter. I am really excited to bring you today's episode. Please do check out the links in the show notes where you can find the podcast website, social media and support group, as well as a link to buy me a coffee if you are able. You should not rely on any medical information contained in this podcast and related materials in making medical, health-related or other decisions. Please do consult a doctor or other health professional. I love to hear from you. If you've got any suggestions or feedback or just want to say hey, then please do get in touch. I really hope you enjoy this episode, so here we go. Hello and welcome to this episode of the Long COVID podcast. I'm delighted to have two guests with me today. I've got Dr. Henry Mahncke and Dr. Gitendra Uswatte. And we are going to be talking a bit about research and the brain. And, well, these guys are going to tell you a lot more about it in just a moment. So I'm really excited to dive into all of this. Welcome, both of you. I'm so excited to have you here.
Thanks. It's a delight to be with you.
Thank you, Jackie.
So it's lovely to be kind of discussing research and stuff that we can do. So before we kind of dive into all of that, can you just give us a little bit of an overview of who you are and what you do?
Sure. I'll kick us off, and then I'll kick it over to my friend G here. My name's Henry Mahncke, and I'm a neuroscientist by training. I did a PhD in neuroscience at the University of California, San Francisco, so I'm out on the West Coast here. And I had the amazing opportunity to do my PhD research on the topic of brain plasticity, which is this incredibly important and exciting idea that the brain can actually rewire and change itself. It can change its structure and its function and its chemistry by learning and experience and training. And I'm sure we'll dig into more of that as we talk. But, after my PhD, I actually worked for the British government for a short period of time. I worked for your Foreign and Commonwealth Office, where I served to build scientific partnerships between the US and the UK. And then one day, my PhD advisor came to me and he said, "Hey, remember all that brain plasticity stuff you did? We've helped a lot of rats build better brains and we've helped a lot of monkeys build better brains. Don't you think it's time to help people build some better brains?" And so that led to the founding of our company, Posit Science, where we make Brain HQ, a software-based brain training program. And we'll probably talk about that in more depth too. But that's what brings me to the podcast. We have a tremendous interest in helping people with all kinds of brain health issues with the power of brain plasticity.
My name is Gitendra Uswatte. Jackie, you're welcome to call me G. I'm a professor of psychology at the University of Alabama at Birmingham. I was trained as a clinical psychologist, and my specialty is rehabilitation psychology. My research for many years was in physical rehabilitation, studying actually how to harness brain plasticity to help people with strokes and other kinds of brain injuries to recover movement, to use their stroke-affected hand more effectively, to walk again. And in recent years, really the last 4 or 5 years, I've turned my attention to cognitive rehabilitation, starting with stroke, and then that was a pathway into my more recent work in long COVID.
So, what really excites me is that there are things that help people. So what I would love to know is you are developing this Brain HQ, and maybe we can talk a little bit about what it is, but also what made you think that was going to help with long COVID, for example? What kind of led you down that path?
Yeah, why don't I say a few words about brain training and kind of what it's all about, and then G, I'll throw it over to you, and you can kind of tell the story of how you got interested and began and kicked off this study. So, what Brain HQ is it's a software-based brain training program that runs on, laptops, computers, phones, iPads, Android tablets, what have you. And it takes this basic science idea that the brain can reorganize itself through learning experience and training and turns it into, well, a brain training program that just about anyone on the planet can go ahead and do. And what Brain HQ is it's a large set of brain training exercises. And these exercises cover all kinds of cognitive domains. There are exercises that focus on speed and attention and memory, and even more advanced cognitive skills like people skills or navigation or executive function and decision making. But every one of these exercises is built on the same scientific foundation. And that foundation is the idea that if we can speed up information processing in the brain, if we can make information processing in the brain more accurate, then we can make the brain just overall better at processing the information that comes into us through our eyes and our ears. We can give better quality information to the parts of our brain that are involved in working memory and attention and decision making. And if we do that, well, the whole brain's just going to work better, and people should perform better on cognitive skills, and they should perform better in real world skills. And this is kind of a new approach to thinking about rehabilitation. And G, you'll probably talk a little bit about kind of the history of this as you chat. But that's what we've done, is taken this basic science out of the lab and put it into the world. And, as we got going, we wanted to not only build a brain training program that was sensible from a scientific perspective, we wanted to build a training program that really had been shown to work in clinical trials, just the way a drug manufacturer or a medical device manufacturer would be expected to do. So as we built the first versions of Brain HQ, we actually ran large-scale studies, first in aging, where we partnered with Mayo Clinic and the University of Southern California, and actually did, at that time, one of the largest studies that had ever been done with a broadly available brain training program, and showed that in people who were just undergoing normal aging, that we could significantly improve their memory and their attention and their everyday cognitive function. And that was an incredible breakthrough, because I think until then, a lot of people had thought about aging like, well, it's kind of a one-way street of cognitive decline. As we get older, our brain gets worse, and hey, maybe it gets worse faster for me and slower for you, but we're all on that path and there's nothing to be done about it. And what the science of brain plasticity showed, and what that first study showed in particular, was, hey, that's not true. We should think about the brain as something that is constantly rebuilding itself. And if we ask it to do the right things, we can build a stronger, healthier brain that serves us better. And that first study just kicked off a wave of research at labs across the country and around the world that was focused not only on aging, but asking this question in all kinds of other brain health conditions, like neurological conditions and psychiatric conditions, just about all of which people have some degree of cognitive impairment. And more scientists began to ask, well, hey, can we treat these symptoms? Can we improve brain health and cognitive function in people across the spectrum of brain health conditions, whether it's aging or more significant neurological or psychiatric conditions? And more and more of those studies started to come in positive, saying, hey, we just need to change the way we think. We need to not think of these conditions as, hey, a person who has one of these brain health conditions is always going to have poor cognitive function and poor brain health. But in the same way that we can think about improving their physical health, we can think about improving their brain health as well. So that's what led us to build Brain HQ, and that's kind of what's led us down this scientific path. And then I suppose one day we got a call from UG at University of Alabama, where we've had many longstanding collaborations. People may not appreciate this, but the University of Alabama at Birmingham is actually kind of a hotbed of brain plasticity research with all kinds of cool projects going on. But we heard from UG.
As I was saying, our pathway into studying long COVID brain fog really started with stroke, and stroke was of interest because slowed cognitive processing is common in many adults with stroke with cognitive impairment. And Carlene Ball, who developed the original version of the cognitive processing training software here at UAB, is in my department. So she was a natural person to partner with to identify a way to rehabilitate slowed cognitive processing in adults with stroke. And so I began this work with Carlene and Ed Taub, who was my mentor and then longtime colleague. And so we married the cognitive processing training approach that Carlene had developed with techniques from what we call CI movement therapy for uh, promoting transfer of gains from the treatment setting to everyday living. And I'll talk more about that later. So it was really kind of a marriage of work that Carlene had done and work that our lab had done. And we did a case series, small case series in adults with stroke, very, very promising results, observed really very large improvements in performing everyday activities, improvements in cognitive processing speed, and one day Ed and I were, just sitting around and chatting and talking. Of course, COVID at that time was on everybody's minds. Um, uh, um, talking about how there was data coming out that slowed cognitive processing was also a hallmark of long COVID brain fog. And then it just seemed sort of a natural to say, hey, if it works in adults with stroke who have slowed cognitive processing, uh, plus some overlaps in the type of damage that occurs to the brain because there's damage to the vasculature in some people with long COVID and damage to the vasculature in the brain. Um, it was just sort of a natural next step to test the intervention we had developed in people with long COVID brain fog.
And it's so interesting as you raise that because my own journey as a cognitive scientist, as a neuroscientist, was when we built Brain HQ originally, we thought about aging. And if you read the literature on aging, or if you just talk to older people that you rapidly find out that hey, just about everyone to some extent feels like hey, I'm slowing down a little bit. My attention's not as sharp as it used to be. My memory's not great. It doesn't mean you have Alzheimer's. That's a much more significant condition. But, these sort of mild levels of, increasing cognitive difficulty show up. And, as I, went forward with Brain HQ over the years, and I started to talk to more and more clinicians, and, I talked to clinicians who are involved in multiple sclerosis, for example. And when you talk to people who have multiple sclerosis, well, what do they say? Hey, I feel like my brain is slowing down a little bit, and my attention's not as sharp, and my memory's not quite as good. And then we talk to people who are involved in studying cancer and chemo brain. And hey, when you talk to, for example, women who've gone through breast cancer, what do they say? Well, I'm slowing down a little bit and my attention's not as sharp and my memory is not so great. And then when the COVID crisis hit, it wasn't that long, probably 6 months into it, where the first patient report started coming, where people said, hey, I've kind of gotten better from the infection of COVID, right? I don't have the immediate respiratory symptoms, but boy, I've not bounced back, right? My brain just feels foggy. I feel like I've slowed down. My attention isn't as sharp. My memory is not so great. And I remember reading those first patient accounts and thinking, holy smokes, maybe this is, going to be representative of something that is, sadly not that uncommon after COVID, but maybe there's going to be some underlying similarities to these other brain health conditions that we've been aware of in doing trials. And that's what was both scary from a clinical perspective, but pretty interesting from a, hey, do we have something new from science we might put together to help people?
We'll be right back. I'm interrupting myself for a second to tell you about long COVID breathing. The fabulous Vicky Jones and I have teamed up to bring you long COVID breathing. We are both passionate about sharing our expertise and experience of the breath and how incredibly helpful that can be with long COVID. We've worked together to develop a course that is specifically tailored to those with long COVID. It's a 6-week course with 12 sessions, all delivered online. The community feel and learning that we're all sharing is such a joy. To find out more information and to sign up for our courses, workshops and other shorter sessions, please check out the link below, longcovidbreathing.com, or email longcovidbreathing@gmail.com to start your breathing journey with us. And to just go back to something, Henry, I think it was that you mentioned earlier, the sort of physical health and brain health, I think you said. Now, what's the difference here? We often talk about physical health and mental health. So, brain health, is that the same as mental health, or is that another category? How would you sort of class that in the sort of spectrum?
It's a great question. I think of the term brain health as almost bridging between the physical health and mental health. And the reason I say that is this, you know, um, the brain is, of course, is part of the body, right? The brain is, 3.5 pounds of kind of wet, squishy goo that sits inside your skull. And just like your heart can be healthier or less healthy, or your liver can be healthier or less healthy, hey, your brain as a piece of biological tissue can be healthy or less healthy. And that's the sense in which I think we have, thought so much and learned so much about how to keep our hearts healthy and how to keep our livers healthy and how to keep our bodies healthy. But often we think about that kind of from the neck down.
Mhm.
And we should remember that, hey, that we can keep our brain healthy, probably with some of the similar techniques, but also some different techniques and keep that healthy. But, it serves as that bridging concept because, of course, when we think about mental health difficulties, if we think about depression or anxiety or stress or more significant mental health conditions like mental illness, like schizophrenia or bipolar disorder, those aren't imaginary psychological issues. Those are very real health conditions that emerge, well, fundamentally from the health of the brain. And so I tend to think of physical health and brain health and mental health as all actually kind of very deeply related in that sense, that these are true issues that emerge from the health of different biological systems. But I often do use the term brain health because as we are thinking about building tools, and Brain HQ in particular, we are thinking about improving the health of, again, those 3.5 pounds of goo inside your skull. And that's a very different approach than other approaches that are perfectly valid and helpful in mental health. Talk therapy, for example, is clearly helpful for depression. All kinds of behavioral therapies are helpful for schizophrenia and bipolar. They probably work by changing how the brain works. That's how they help improve mental health. But we often talk about brain health at Brain HQ because we really do want to come at this from a very neurobiological perspective. Let's help improve the health of the brain. Let's fix information processing, and then people should see these broader benefits. But I don't know, G, how do you think about that spectrum as you go from physical health to mental health?
So I think, there are multiple pathways to impact brain health, and it can be done by changing how people think. That's one way. But it also can be done by diet. So really sort of physical interventions. Diet, it can be done through electrically stimulating the brain in different ways, like transmagnetic magnetic stimulation, for example. But it also can be done through training exercises, and that's the approach used by Brain HQ, and that's the approach we take in our study, that by exercising capacities of the brain in the right way, you can improve how it functions, and we believe that that improvement in function is reflected in changes in the very structure of the brain.
I love this idea of brain health being the sort of what umbrella that joins together your physical and your mental health. I think that's brilliant because our brain, it sort of sits at the top of our, well, literally sits at the top of our body, doesn't it? And it impacts every part of our body, doesn't it? I'd love to hear more from you guys about, why is our brain so important? And if we improve our brain health, is that going to impact, therefore, all parts of our body and therefore potentially not just, I say just, brain fog? Brain fog is quite significant. But is it going to also help other symptoms in other parts of the body as well as just, again, using that word, the sort of brain fog and cognitive issues that a lot of people describe?
So of course, the brain connects to all our organs, so it controls how all of our organ functions. But interesting how Henry's talking about how the brain and the body are connected, right? So, as our understanding of human beings grows, there's sort of a mini brain in our stomach, right? There's, uh, right? So, and also, they're parts of the nervous system that are connected with the heart that also are connected to uh, uh, how our brain functions. So there's kind of a two-way street between uh, our our brain, the centers of the nervous system that control the heart and also that control digestion and other functions in the gut. And so there's kind of uh, sort of a two-way street here. And when we get to talking about the latest things we're doing in the lab, the vagus nerve, which connects the brain to many organ systems, um, uh, is one way we are now trying to affect brain health too. But I will come back to that later and flip it over to Henry for now.
Yeah, no, G is exactly right, of course. And hey, cards on the table. I'm a brain scientist, so you're going to hear from me that the brain's pretty important. But maybe that's why I became a brain scientist, is because I thought the brain was really important. For all the reasons you just said, and then the brain, of course, is the center of your experience, right? I mean, your memories, your experiences, your even, I would argue your sense of connection with the greater humankind and the greater world. These are all mediated through your brain. And how well your brain is working as a result just has an enormous impact on everything you do. In of course, very direct scientific ways, right? Hey, if your attention is not so good, if your working memory is not so good, you're going to have challenges in everyday life, right? It's going to be more of a hassle when you get to the ATM or you're trying to check out at a grocery and you're trying to remember your PIN number, or you got 16 people behind you who are upset because you're not bagging your groceries fast enough, right? These kinds of cognitive abilities have these kinds of real world skills. Think about driving safety, right? Particularly in older adults, but I imagine it's true in just about every kind of health condition. If you have a slower visual processing system, hey, you're much more likely to be involved in a car crash, right? You're not going to notice something coming out of the corner of your eye until it's too late. As my dad got older and he had difficulties driving, he would say, "Well, that car came out of nowhere." I'm like, "Well, Dad, I'm not really sure it came out of nowhere. I think that your brain has slowed down a little bit and you just didn't notice it in time to be as safe as we would have liked you to." So, your brain affects your cognitive function in all those kinds of important real world ways, but it affects your mood as well, right? If you have a less healthy brain, you're more likely to suffer from some of the mental health issues we talked about, like depression, anxiety, or stress. And of course, if you're feeling foggy all the time, that's an enormous challenge, as you and your listeners know, Jackie, around, hey, your ability to be with your family, your ability to hold down or succeed at a job, your ability to be part of your community. So the brain is just at the center of all this. And I think it's only recently that we've started to take that seriously because we've had a physical health revolution, right? Everyone has the idea that we can change our physical health with some of the things actually G mentioned, right? With exercise and with diet and various things like that. And so, we have different genetics and we have different lived experiences, but, to a large extent, we can change our physical health outcomes with those kinds of things. But we haven't really realized until more recently we can do the same for the brain. Like I still talk to people and who are older, for example, and we'll talk about the risk of Alzheimer's, and they'll say, "Well, my dad got Alzheimer's when I was 82, so at some point, the alarm clock's going to go off for me, and I'll have Alzheimer's. Nothing I can do until then." I'm like, well, that's a terrible way to think about brain health. There's a lot of things you could do to change your risk factors. Or even more broadly, I'll talk to people who say, "I've never been good at math, right? I'm terrible at languages. I can never learn French." Like, well, I actually really do not believe that nobody is capable of learning French or being good at math. I believe you might have had life experiences that have told you you were bad at those. I think you might have had educational experiences where you had bad teachers. But hey, everyone can learn math and everyone can learn French. And that's because the brain is incredibly powerful that way. But we're just now starting to move out of this very fixed notion that my brain's kind of like a computer chip. It's wired the way it's wired. There's nothing I can do about it. And we're only starting to now enter this kind of period of a brain health revolution where we recognize, hey, there's lots of things we could do to improve our brain health and change our cognitive function. And hey, we should start thinking about that both at the personal level, but frankly, also at the societal level and the policy level as well. So anyway, brains are important. That's our
Yeah.
perspective as brain scientists here.
Yeah. And I want to talk a little bit more about cognitive processing speed and why it's central to cognitive function and to long COVID brain fog. Right. So, and I think Henry touched on this, right? So, it's cognitive processing speed is a sort of a basic capacity of the brain, um, and it speaks to how efficiently we process information that we take through our senses. So, the example of driving, you come to an intersection, right? Uh, you see a red light, that's a signal to stop. And then when you're sitting at the light, deciding to go again, right, you may look for pedestrians crossing, somebody may honk their horn, right? And all of that is information coming through our senses, and then that's processed at higher levels in the brain, and then ultimately that feed making a decision about whether to go or stay. Yeah. Or if you're reading, right, that is also a matter of processing information that we're taking in through our eyes. So it is a basic cognitive capacity that underlies many other cognitive functions. And it ties to the experience of long COVID brain fog. I mean, many people with brain fog talking about experiencing slowed thinking. And also they talk about like having trouble bringing up a memory or holding a memory, and processing speed, how efficiently process that affects our working memory, which is key to sort of connecting one thought to another. And people with brain fog also talk about difficulties making decision. And again, that's connected to working memory, because you've got to hold the pieces of information necessary to make the decision in your brain. And if they're not arriving in synchrony, or one piece is taking a long time to get there, that sort of assembly of information that's needed to make the decision are not present in synchrony, and then that sort of can fall apart.
Yeah, it's like, the real world example, that kind of oh, that word, it was on the tip of my tongue and it's gone. That kind of, not quite being able to lay your hands on things. But what I hear from people who experience the kind of, more severe end of things like brain fog, it's, almost sort of things like dissociation and not being able to really understand where they are, or finding it cognitively, finding it hard to speak, not just I can't find that word, but like I can't find any words. And these kind of real difficulties with being able to sort of, yeah, put those pieces together. It's like, the pieces are just everywhere. There's putting them together is like they're not even on the same table. So yeah, it sort of makes sense when I hear you sort of describe some of these sort of different ways of processing, and how important that is, in functioning as a person in life, which I think is what people with, long COVID really feel like they're not part of life a lot of the time. Certainly that was my experience. I was living this kind of like, parallel life of a person in this little weird bubble, and the world was going on outside, and I just felt completely disconnected from it, which was really, well, it was quite unpleasant on many levels. Now, I'd love to kind of touch on, before we get stuck into the study, the issue of it's all in your head. Now, physically, your brain is all in your head. That's where it is. It's that, what do you say, 3.5 pounds of squish that is based, housed in your skull. But we've talked about how important the brain is in processing, and our nervous system, which controls so much in our body, all those signals that go everywhere.
Mm.
what people find distressing is, if they feel like they're being told, oh, well, it's all in your head. These symptoms are caused by your brain or they're not real. And I think everyone with long COVID is very aware that these symptoms feel very real. Um, but I'd love to kind of hear your kind of take on where does the brain health fit in this debate? So I'm going to throw that one out there and see where it lands.
Well, there is persuasive evidence that there is damage to the brain as a result of COVID-19 infection in many people. Uh, so there's evidence that there's damage to the vasculature all around the body, including in the brain. Um, there's evidence of chronic inflammation in the brain. And there's also evidence. We were talking about the vagus nerve and its importance and its connections to the brain, and so there's evidence that the virus actually attacks the vagus nerve in some people. So there are many pieces of evidence that COVID-19 damages brain tissue.
We'll be right back. Hey there, I'm just jumping in for a second to see if you're enjoying this episode. If you're finding it useful, maybe you would consider sharing it somewhere, a friend, a group, or even on your Twitter feed. If everyone was able to share just once, we'd be able to get this information out to even more people who really, really need it. So please consider sharing somewhere if you possibly can. I hope you enjoy the episode, and thank you so much.
Yeah, that's absolutely right. And in a way, we've like seen this movie before, right? So one great example is, of course, the history of chemo brain. And cancer, of course, historically a deadly disease, and most people passed away. And as medical treatments got better, we started to have more and more people surviving cancer. We had many more people entering long-term remission. And as that happened, of course, patients started to say, "Hey, I may have been in remission from cancer, and that's wonderful, doctor, but hey, I feel foggy, right? I have these brain health conditions." And if you look at the history of chemo brain, it looks exactly like the emerging history of long COVID, which is at first doctors, did not take it very seriously. And, I suppose the kindest way to say it would be, I think oncologists were perhaps feeling like, hey, we have put your cancer in remission. You should be very happy with this outcome. And it's fair to say that's a great outcome. No debate there. But, as we have survivors, different issues emerge. And, oncologists are wonderful clinicians, but they're not cognitive scientists. They're not psychologists. They're not occupational therapists. And, these kinds of complaints were just new and different and foreign to them. And so, there was this, I think, idea at first that, hey, this is all in your head if you say you have chemo brain and it's going to get better on its own, or, just pep up a little bit, get off the couch, right? But now, of course, we know that there are, as G said, for long COVID, we know that there's, kind of distinctive issues that show up on brain imaging scans for patients with chemo brain. We know they have very distinctive patterns of neurocognitive results. And I don't think anyone would say anymore that chemo brain is simply a made up phenomenon, or that it's a psychological phenomenon. It's clearly a very real consequence of cancer or cancer treatment. And, with long COVID, I think we're speed running that, which is good, right? Some of the initial comments may have been, hey, this is all in your head, or it's not a real phenomenon. But I think a lot of people, like me, and I imagine like G, sort of said, okay, but we've been through this in other indications. Let's just jump ahead to the end where we realize that this is a real biological condition. Nobody wants to feel this way. People who have these complaints, I think, really do want to get better. So let's figure out what we can deliver to them. Now, that has all kinds of interesting implications. I mean, even though chemo brain and long COVID, for example, both are true brain health conditions, as G said, they probably can be helped by a spectrum of interventions. Again, talk therapy helps with depression by rewiring the brain. brain, right? You can see changes in brain imaging after talk therapy. So I wouldn't want anyone to think that talk therapy for depression is means that that person really wasn't depressed. They just got talked out of it. That's not really how talk therapy works. I think a lot of interventions are going to be helpful for people with long COVID. Cognitive behavioral therapy, I think, will probably be shown to be helpful over time if it hasn't already. All kinds of occupational therapy kinds of approaches and these kinds of things. And I think that the stuff that we at Brain HQ and G at University of Alabama have pioneered with brain health treatments are going to be helpful as well. But none of it means these are made up symptoms or they shouldn't be taken seriously. It means they are real biological symptoms. But the good news is we have a lot of tools in the toolbox that I think we can bring to bear that are going to be shown to be helpful over time. And I'm an optimist by nature. That's my sense of where this field is going.
Yeah. And this idea as well that just because it might be in your brain doesn't also mean that it's not in your body as well. Because, we started this conversation out, didn't we? You saying, well, brain health is body health, brain health is mental health, it straddles the two.
Yeah.
So, I think, you can't really separate the two. They are all so connected.
Well, it's almost hard for me to even answer the question. I mean, I get that it's a question out there in the world, but I'm often just so stumped by this. Where else would it be coming from exactly? So,
Now, G, you mentioned damage in the brain, and that this has come up on studies and MRIs, I think. Now, we started this conversation off again by talking about neuroplasticity and how the brain does change and can change. And so, damage that is showing in the brain, is this something that through neuroplasticity, through improving our brain health, that can be reversed or improved upon? Or is damage in the brain, is that like forever?
My lab's approach and the way I think about it is our interventions harness healthy aspects of the brain. Um, I don't I don't hypothesize that our interventions are healing the damaged brain tissue, but rather that it is taking advantage of healthy tissue and sort of redirecting healthy tissue to take on other functions. And actually, healthy tissue can grow. So it's not like a close sum, right? So we may be actually increasing the amount of brain tissue that is committed to a particular function, but it's not healing or repairing the damaged tissue. It's repurposing and regrowing healthy brain tissue is what I understand what our approaches are doing.
it's probably here worth jumping in and saying sort of the differences between the kind of damage that G and I are talking about. When we think about damage in the context of, let's say, long COVID or chemo brain, it's not like stroke damage. And obviously, you've worked a lot in stroke, but probably listeners know, hey, a stroke is you fundamentally have had a brain bleed or something of that nature. And, there's a definable, like, anatomical part of your brain that, literally is quite damaged by this or, dead to some extent. And, as we think about rehabilitation for that, like Gia is saying, we're not bringing that part of the brain back to life. That's unfortunately not quite how the brain works. But as G says, we're encouraging other healthy parts of the brain to kind of take over and kind of through the power of brain plasticity, take on those functions that were previously performed by the damaged piece of the brain. With long COVID, the damage is much, much subtler. It's not like there was a specific part of the brain that was, damaged by a bleed or a traumatic brain injury where you have a chunk of your brain that just gets damaged by an impact. With long COVID and probably with chemo brain and all these other kinds of conditions like this, it's more like across lots of the brain, there's a little tiny bit of damage. But as a result of it being so pervasive across all parts of your brain, as a result, your brain is less good as an information processing system. Sometimes at my company, we talk about it kind of like being a radio that's kind of gone off the signal, and there's kind of a little more static in brain information processing because, where we used to have 100 brain connections called synapses that were all doing their job, maybe now as a result, we have 98. And it doesn't seem like a big change, but if you lose two at every point of your brain information processing, then hey, things aren't working so good anymore. And so, in healthy aging, there have actually been quite a lot of brain imaging studies now that show, hey, how does this work? How does brain training work? And we see all kinds of changes, right? We actually see, for example, that the insulation that surrounds the wires, so to speak, that connect different parts of the brain to each other can get more thick. We actually see that, hey, if you sit around doing nothing in a brain imaging system, we can actually see that different parts of your brain are more in sync together than they were before training. So we're restoring that kind of broad neural connectivity.
Mm.
We can even see that the brain becomes more activated during certain cognitive tasks after brain training. And so in that sense, it seems like we are, I'll broadly say fixing the brain or improving brain health to do these tasks, but it probably is through this very diffuse process of rebuilding the brain so that, hey, maybe we lost two synapses and every sort of point in information processing, and hey, we grew two back, and probably not the ones we started with, but we grew two back that are doing the same task in some kind of helpful way. Now, to be clear, that hasn't been shown in long COVID yet, or many of these other conditions like chemo brain. But if they work out like aging, I predict that's what we're going to see over time as those scientific studies roll in.
So it's like replenishing, isn't it? Sort of replenishing the brain rather than fixing the bit that is broken.
Yeah, that's a good way to think about it.
So in our latest work, we're pairing vagus nerve stimulation with cognitive rehabilitation. Uh, and there, our hypothesis is that the vagus nerve, by stimulating the vagus nerve, we will turn down chronic inflammation, including in the brain. And so there, we our hypothesis is that our intervention would repair the brain. Yeah.
That's a really kind of novel technique, and really kind of pushing forward the boundaries of how we think about rehabilitation. That's very cool, G, because you're kind of mixing, software brain training and, of course, the intensive coaching from your CI coaching approach, and then this very novel approach of brain stimulation and bringing together all these
Yeah.
modalities to, hopefully supercharge what we can do from a rehabilitation perspective.
Yeah, I'm very very excited to see what the results are when we unblind the trial. Yes.
Yeah. So yeah, I love this idea of like pairing stuff. It's like, there's so many things out there that people are seeing improvement with. So okay, let's shove some of them together. Why not? That's such a cool thing. So we've kind of talked around it a lot. But this trial, so let's get into that a little bit and what is involved and what is starting to be shown.
So in the study that was just published, um, we pair three components. One, brain training using the double decision part of Brain HQ, um, which targets cognitive processing speed. Then we do uh, training in in the clinic on performing everyday tasks. So these that can range from setting up appointment calendar, uh, shopping for an item on the internet, writing an email, um, setting up a grocery list, right? So training on everyday tasks, but we do that in the treatment setting. We organize it using a psychological approach to training called shaping. Um, and then um, the last component is a set of behavior change techniques that we call the transfer package. And those are aimed at uh, promoting transfer of the gains that are made in the therapeutic setting to everyday life. And these are things like goal setting, um, self-monitoring, and problem solving. And it's those are the three components of the intervention. We call it CI cognitive therapy, and it is done on an outpatient basis, and now to 30 hours over 2 to 4 weeks is the dose we're testing now. Yeah. Um, and in the study that was published, we compared it to what people get sort of through usual care, which at the time, in where we were, where we are in Birmingham, was largely nothing. Folks were really not getting offered treatment in the community at the time we did the study. And the findings were really striking. The one that really got my attention was we found that 80% of those for whom getting back to work was relevant did so in the CI cognitive therapy group, and none did in our usual care group. Um, Small study, 7 and 7 in each group, but really striking finding that got my attention. Um, then, in addition to that, we documented that they were uh, very large improvements in performing everyday activities in the CI cognitive therapy group, um, large improvements in fatigue, very large improvements in brain fog symptoms, and very large improvements in depressive symptoms. So, large changes across the board. I will qualify it's a small study. We need to verify those in subsequent studies, but we're doing that work now. We have a second study underway, as I was mentioning, to see if we can confirm the results from this initial study.
Yeah, this is super cool. I mean, I'm coming in here from a background who I'd never understood research at all until I started interviewing researchers on the podcast, which kind of blew my mind because suddenly it was like, wow. And what I hadn't really understood was that in research, you got to start somewhere. You do a little study, and then you do another study, and then you do another study, and each one kind of takes you further, gives you more and more answers. It opens out more and more, and you're able to maybe direct things more and more as you get more answers. So that sounds like so what you've sort of started with the little one, and you're now moving into the next one, which is going to start giving you more and more answers. And the more answers you get, the more you're able to help people because you're able to direct them to, I suppose, certain things where you're starting to see results. So is that correct?
Yes, yes. I mean, science is a sequential process, and one study builds on the other. Yes.
And as a creative, I'm like, oh, you've got to be logical. What?
Oh, there's always more overlap than I think. Science is itself a very creative process, and I think a lot of creative prop people move step by step as well. So I always like to look for those similarities. And I want to emphasize that what is so cool about the study that G did is by combining those three components that he talked about, right? When we think of the Brain HQ component, we think about something that we almost call bottom up, right? We think about it as fixing information processing or improving information processing at the basic level. But of course, he combined that with, hey, let's take down a more what I might call top-down skills training, right? We know what people are struggling with in the real world, your shopping lists and your organizational plans, and let's give them real skill training, almost the kinds of things that occupational therapists or cognitive rehabilitation people would offer in the clinic. And then, of course, that's marry that with some coaching that really helps people, set goals for themselves. Because, hey, everyone's goal in improving their brain health is different, right? Some people want to go back to school, and some people want to take care of their family, and some people, want to be able to, get outside and enjoy the world. And by, connecting the dots to, hey, what's really important to someone with these other skill things, it really brought together what you've correctly called, G, a package, right? That really says, hey, we need to come at this from all these different angles to have the hope of really delivering something helpful. And of course, you got these spectacular results showing improvements in cognitive function and symptoms like fatigue and getting people back to work. And so it just was a very thoughtful and creative approach to pulling this together.
And this is a very small study, but even so, like you said, 80% were able to return to work in some form. That's huge, even despite it being a small study. So, as you're able to move this into sort of bigger numbers and expand it a bit, I'm super excited to see what that shows,
Mhm.
and hopefully continues that trend. Now, you mentioned the different tasks, the three different tasks. And are these all targeting different parts of the brain or different types of processing? Is that why you picked the three different sort of things?
I would kind of build on what Henry was saying. So I think about it as the brain HQ component, the training on cognitive processing speed. That's training a basic brain capacity, uh, and then by doing the training in the lab on everyday tasks, we're giving our participants the opportunity to practice the improvements in uh, to apply the improvements in cognitive processing speed. We're giving them opportunities to practice applying those improvements to actual tasks. And so it's a sort of scaffolding or a bridge from the cognitive processing to everyday tasks. And then we have a second bridge, which is from what they're doing in the lab setting to their everyday lives. And that's how I think about it. Yeah.
Yeah, I agree. I think of it less like targeting different parts of the brain and more like targeting almost different levels of organization in the brain, ranging from the most basic, like how does the brain processing information, to this sort of very intermediate, how's a person tackling real world tasks, to this very high level in the hierarchy of, hey, how's a person thinking about their goals and how's a person organizing their work ahead of them. And it's by coming at this from all these levels of the hierarchy that I think the approach turned out to be so powerful.
And it's making it like useful in people's lives as well, isn't it? I mean, you can do brain training on the brain HQ, and that's great. And you can say, I'm improving my brain health. That's great. But then when you can sort of use it in your daily life and go, oh, I can do that thing, or that's helping me to do this, or that's actually showing up in parts of my life. That's what people really care about, isn't it? It's that it's making a difference rather than it's improving a metric, I suppose. So it's sort of building that up, isn't it?
I like to talk about it as making it meaningful. So, for example, for one of our participants, one of their goals was to build a beauty website, right? And so we directed the things that she practiced every day in the clinic towards like working on those skills that she needed to do that. Or for another participant, it was like, her long COVID had affected her functioning so much she felt like she had lack of confidence about caring for her children, right? What could be, more meaningful than that? So, we work with her on that. Yeah.
I almost want to draw this analogy to like physical performance training from what G is saying. Imagine I'm in the States, so I might think of basketball, but in the UK, you might think of football, I suppose. But, let's say you're in charge of physical performance training for your team, right? You probably want to do some training that's at the very basic level, right? They're going to spend some time in the weight room exercising particular muscles. They're going to do some just basic running and endurance and speed training to build that foundation. And then you're going to have this middle layer, which is, hey, let's work specifically on basketball skills, right? We're going to practice our 3-point shots. We're going to do our no look passes, right? We got certain formations we're going to run. And then at the top, you have motivation, right? You got a coach who's like, this year we're going all the way to the finals. I want to see every one of you with a trophy and a ring in your hands. And, it's only by bringing those kinds of three levels of the organization together that you have that winning team. If you were missing any one of them, they wouldn't be performing. But by bringing them all together, you're developing like optimal physical performance. And I think, G, what you sort of put together there is kind of that same logic for developing, better brain performance and better cognitive health.
Amazing. So maybe just very quickly, finally, people listening are going, okay, this is great. Very happy for those people in the study. How is that going to help me right now? So Brain HQ, I think, is available for people to use. And you can maybe say that a bit about that in a moment. And
are any of these other things that you used in the study available for people to access?
So that's exactly right. The Brain HQ component of this study is available right now to anyone in the world, and in fact, anyone who wants to try this out, the great news, anyone can come to www.brainhq.com. You can register for free, and we'll actually give you one free exercise per day to sort of try out and see if you like it. And hey, if you do decide it's for you, a person can subscribe, and it's really relatively inexpensive on the scale of things. And hey, we've got users, all over the US and the UK and all over the world. Brain HQ is available in 14 languages, and hey, lots of people who want to maintain their brain health, to improve their brain health, recover their brain health, are out there using Brain HQ today. But that being said, in general, I would encourage someone who wants to improve or maintain their brain health to come register for free and give it a try. But of course, as we've talked about, Brain HQ was one component of this more broad piece. And so, gee, when you think about the broader piece, do you think about training occupational therapists? Do you think about publishing a book that tells people how to do this? Do you think about running a center where people come to the University of Alabama and learn these techniques? I mean, how do you imagine that the other elements of this sort of start to get out into the world so you can help people?
I would like to do all of those things. I think, indeed, indeed. Uh, but I think the first next step is completing this second study and uh, confirming the results from our first study. But uh, you know, as Henry was saying, BrainHQ is available around the world. It's on the internet and right, can be logged in, access through the BrainHQ platform anywhere. Um, and then, the other parts of the CI cognitive therapy, they're not high tech, and so they with proper understanding and training, uh, psychologists, occupational therapists anywhere in the world could implement the intervention. So it has the potential to be broadly available as a result. And we are working on developing a telehealth version of the entire intervention. Of course, Brain HQ is already a telehealth intervention, so to speak. It's available on the internet. Um, but we're working on developing the other parts in a telehealth format, so then we won't be restricted by geography. And then the other pieces, we do have an ongoing study here in Birmingham, Alabama. You'd have to come to Birmingham to take part in the study, but we are enrolling folks in the trial. The telephone number for the lab is 205 934 9768. That's 205 934 9768. Or you could Google Uswatte, that's my last name, Uswatte long COVID cognitive rehabilitation, and you'll be able to get to our lab. Yeah.
And to step back, I think the world that G and I would both like to see over time is, hey, that world where people's cognitive symptoms, their cognitive complaints after long COVID, taken very seriously as a true issue of bodily, by which I mean brain, by which I mean mental health. And that, hey, when a person has those symptoms because they just didn't get better after COVID, that there are resources that they can reach out to, whether it's their doctor or rehabilitation clinics or telehealth clinics, the way that G has laid out there. And those resources are available to them. They're part of their ordinary health care treatment, right? You might need an inhaler because you have, asthma symptoms, and you might need this kind of cognitive rehabilitation because you have cognitive symptoms. And that's an ordinary thing. When you say, hey, I've got fog after long COVID, your doctor says, well, great news. This resource is evidence-based resource. This proven resource is available to you, part of your health plan in the US, part of the NHS in the UK. And hey, here's who you call. Maybe you're going to go in and visit visit a clinician in person. Maybe you're going to do this in telehealth. Here's your Brain HQ subscription. Hey, you're going to get a very focused period of treatment. G has talked about 30 hours of treatment over the course of just really a few months. And then, hey, we're going to check in. We're going to see how your cognitive symptoms are. Maybe we'll do a brain scan, see how your brain is doing. And hey, and we're going to ask you, most importantly, and if you're feeling better, fantastic, get back to life. And hey, if this hasn't helped you yet, but some more would help you, let's take you down for a second round of treatment. If this exact approach didn't work, let's give you something else. But it should be like any other kind of healthcare you get for your physical health, right? If you go in with an infection and one antibiotic doesn't work, they measure it and try a different antibiotic. Let's get to the one that works. And that's exactly what we want to see, I think, for this kind of rehabilitation and all of these brain health issues, but long COVID for sure. And we're not there yet, but that's the future, I think, that we're all fighting for, that we're all working towards over time.
Amazing. You guys have made me so excited for the brain. Guys, thank you so much. It's been amazing hearing all about the brain, a bit about the study, where you're going next. I'd love for you to come back after you've done the next study, and we can talk more brain. So I will make sure that all those links you've mentioned, the study and of course Brain HQ, go into the show notes. So if anyone is wanting to check any of that out, you know where to go. Henry, G, thank you so much. It's been my pleasure.
Thank you for hosting us.
Thank you, Jackie. It's been a delight to talk with you. And I hope this is fun and interesting for everyone who listens to your podcast. Thanks.
Thank you so much to all of my guests and to you for listening. I hope you've enjoyed it, or at least found it useful. The Long COVID podcast is entirely self-produced and self-funded. I'm doing all of this myself. If you're able to, please go to buymeacoffee.com/longcovidpod to help me cover the costs of hosting the podcast. Please look out for the next episode of the Long COVID podcast. It's available on all the usual podcast hosting things. And do get in touch. I'd love to hear from you.